OK, so suppose you're deciding what to do, and your options are party or study. Now, other things being equal, you much prefer partying. Alas, there's a test the next day, and you are mindful of the fact that there's a correlation between studying and passing the test. And although it's true that going to the party would give you, let me say, utility points, like it would make you happier, passing the exam would be so much better. So maybe I'm going to say that the difference between partying and studying is 5 points. But the difference between passing and not passing is 50 points. So let me write this down. So the value of failing the exam and partying is 5, because you get the benefit of partying, but not the benefits of passing. The value of not failing, i.e. passing and partying, is 55, because you get both benefits. The value of failing and studying is extra bad. You get nothing. And the value, sorry, of not failing and studying, that gives you 50. You don't get the benefits of partying, but you get the benefits of passing. Apologies for the bad notation. If I had written down passing, then I would have had more than one P. OK. But then, of course, there's a different issue to be mindful of, which is the correlation between passing and studying. So let me say that the probability of failing, given that you party, is 80%. So it just follows from that that the probability of not failing, given that you party, is 20%. If you study, however, then the probability of failing is just 10%, from which it follows that the probability of passing if you study is 90%. So this is what standard decision theory tells us. It tells us that the expected value of partying is the value of failing and partying times the probability that you'll fail given that you party, plus the value of not failing and partying times the probability that you'll not fail given that you party. So in other words, it's the weighted average of what will happen if you party and fail, and if you party and not fail, where the weights are given by the probability that the relevant outcome will happen given that you party. And the expected value of studying is the value of failing and studying times the probability that you'll fail given that you study, plus the value of not failing and studying times the probability that you'll not fail given that you study. And then we can just put in the numbers. So if you fail in party, you get 5. If you don't fail in party, you get 55. That is 0.8. And that is 0.2. So I did the math, and you get 15. The value of failing in studying is 0. The value of not failing in studying is 50. And this has a chance of 0.9. So that's 45. So the expected value of parting is lower than the expected value of studying. What standard decision theory says is do whatever maximizes expected value. Since studying maximizes expected value, standard decision theory says study. And I hope that sounds eminently sensible to everyone. So like in this case, it works perfectly. OK, but now for the bad news.